This is planned to be the final launch of this version of Starship, version number 2. Right now, we're actively building multiple next-generation V3 Starship and Super Heavy vehicles in the factory, kind of right behind us, so let's take a minute and nerd out a little bit. All right, this is going to be launching from Pad 2, which is nearing completion down here at Starbase. Both the pad and the vehicles are going to roll in really significant changes. This is building on everything we've learned from all of these flight tests to make a vehicle that we're looking to mass produce. Starting with the Starship upper stage, which is going to look pretty similar on the outside, but it's getting pretty much a complete overhaul under the hood. We're getting major design changes to its propulsion system that's going to accommodate that new version of Raptor, which puts out higher thrust. We're also getting an energy storage upgrades, tons of avionics changes, a lot of things that will enable longer duration missions. One notable thing you'll start seeing on the outside are these new docking adapters, which we'll use when we bring two Starships together for propellant transfer. That's a core capability of Starship that we're going to demonstrate next year. Bottom line, though, this is the Starship we're planning to use for all of our next major milestones: orbital missions, return to launch site and catch, reuse, propellant transfer, and then making our way to the moon and Mars. Now, Super Heavy, we've shown some of this off, some of this hardware already coming out of the factory. It has upgrades like this, a redesigned fuel transfer tube. That thing's roughly the same size as the first stage of a Falcon 9 rocket. That channels all that cryogenic fuel down to Super Heavy's 33 engines. We made it bigger. It's basically a rocket inside of our rocket that gives us a faster, more reliable flip and simultaneous engine startup. New booster also going to have an integrated hot stage, a lot more vent area, and it's designed to be fully reusable. Pressure from those engine plumes gets vented out, mostly offset just by the pressure in the fuel tank. That is the top of the fuel tank. And then we add a non-structural layer of steel on the top that helps take all the heating. It's mapped to where all the high heating goes. Grid fins also getting a big change, going from 4 down to 3. They're 50% larger, though, much higher strength. They're also going to get used for vehicle lift and catch. That's all made possible. There's a new catch point addition on those grid fins. We've also kind of reclocked their position on the booster. That aligns them with the catch arms. Yeah, we got it right in the middle there. All right, and then powering it all, Raptor 3. Looks radically different, just straight up radical. Tons of major changes. It's coming in higher thrust, dramatic reduction in parts, tons of control mechanisms moved inside. Our McGregor team's built some additional stands like this one, which essentially is the bottom of a Super Heavy booster. Lets us do gimbal or steering tests, so that's been really exciting to see. We've also been getting vacuum versions of Raptor 3 into test. The first flight engines are already in production and are about to start acceptance testing for Flight 12. So a lot of exciting changes coming, and we're getting ready to mass produce everything, including one of the really key contributors to that rapid reusability, the heat shield tiles. Let's jump over to Tyler real quick in Hawthorne, who's got a really cool look at what's happening with tiles in Florida.
Thank you, Dan. Indeed, Starship's heat shield is the linchpin to full and rapid reusability. We can't launch, land, refuel, and launch again if we have to spend months refurbishing the heat shield after every launch, like they did in the Space Shuttle program. So, in a future where Starship is flying several times a day, many, many thousands of heat shield tiles will be required. So yeah, we need to get cooking on those tiles, which is exactly what's happening inside the fully automated bakery down at the Cape. In just 3 years, tile production at the bakery has surpassed the total number of tiles produced during the 30 years of the shuttle program. To go from the raw material to a finished tile, it takes about 40 hours. And today, the bakery is producing about 1,000 tiles a day. But it's set up to produce enough tiles for 10 ships per month, which is about 7,000 tiles a day, or a tile off the line every 13 seconds. So yeah, the bakery is well on its way to providing Starship with all the tiles for missions to Mars and beyond. And for today's flight, we've made a modification to the heat shield tiles. Dan, do you mind filling us in on what's being referred to as the Crunchwrap tile?
Absolutely. I always love to get to do a little show and tell. So we've got thousands of these heat shield tiles covering Starship. Now they're kind of all next to each other. There's a small gap in between all of them. You got to leave a little bit of space as that metal underneath will expand and contract. That way they don't crunch into each other and start breaking. However, that lets some of that plasma kind of seep through, and we see really high heating on the sides and then down on the metal. To help fix that, we have this, the crunch wrap that everyone has heard about. So we take essentially that's called Vulcan felt that we then wrap around. And so as these tiles are next to each other, you've got a small bit in between that's going to help offset that heating. It's just one of the ways we're continuing to iterate on this heat shield, getting towards rapid reusability. Hopefully it's going to help Starship live Moss you know, everything is just going to get us to that end state of a fully and rapidly reusable vehicle. So pretty much the entire vehicle has those on it today. We've done this on multiple Starships previously, but this time pretty much the whole vehicle has it. So that was
Okay, now as we get closer to launch, development continues down here at Starbase, Texas, to shape this growing city into a truly unique place to live and work. And part of being a city, particularly one surrounded by nature, is environmental stewardship. The nearby Boca Beach dunes have unfortunately been eroding at an alarming rate for some time, so SpaceX is teaming up with Cameron County and the city of Starbase to stop that erosion and hopefully preserve the beach for years to come.
Yeah, and as one of its first permanent residents and someone who's actually called Starbase home for over 3 years now, I can tell you the beach totally adds to the uniqueness and awesomeness of living here. Starbase is truly unlike any other place on Earth. You know, where else can you see the world's biggest rocket every single day?
Yeah, Starbase is definitely the place to be, and we're always looking for more people to come help build the future of spaceflight.
Yeah, particularly engineers, especially for our propulsion and mechanical system teams.
You could be working on tests just like these ones, proving out the designs of our next generation Super Heavy booster. Fun fact, we actually tested the booster to 13,400 tons of thrust, which is more than the power of 3.5 Saturn V rockets, which is just crazy. We're also looking for civil and structural engineers to help literally build the future.
Whether it's buildings like the Gigabays currently going up at both Starbase and the Cape, each is a massive vertical integration and assembly facility with over 700,000 square feet of workspace. Both sites are currently in progress, actually going vertical as we speak. Or you could be designing the Starship launch sites of the future. There's really no shortage of future to build here. So visit spacex.com/careers to see all of our openings if you're interested.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have liftoff. Go Super Heavy. Go Starship. Thanks for all the historic flights, Pad 1.
Vehicles pitching downrange. Booster Raptor chamber pressure nominal.
See the engines throttling down.
Booster engine cutoff. Ship ignition. Stage separation. Use backburn startup.
All right, successful hot staging maneuver. So we've got 12 of the 13 engines lit back up on booster, so it's doing its boost back. Real excitingly, though, we've got 6 out of 6 Raptors lit on ship there, so it's now going to continue to make its ascent into outer space.
And as we're starting to get into the denser part of the atmosphere, the booster is using 4 hypersonic grid fins to guide itself through atmospheric entry towards its landing site.
And we're just about 20 seconds away from landing burn start, where we'll first ignite the center 13 engines, then bring that down to 5 to slow down the booster for landing. And finally, that will come down to 3, and we'll cut all of them off while we're still about 200 meters in the air. So booster is going to see a bit of a harder thing.
Booster landing burn startup. Booster landing burn shutdown.
And there we heard it, booster landing burn shutdown. We saw a 13 to 5 to 3 V3 demonstration, and into the water we go.
Less than 30 seconds to go in this ship ascent burn. All right, RVACs have shut off. 3 more to go.
Ship engine cutoff.
All right. All ship Raptors have shut
Nominal
down.
orbit insertion.
Yeah, and anybody that's been following Starship, you know, Starlink's kind of the MVP for these flight tests, where it's not only giving us the views we're seeing right now, but also just real-time data through every phase of flight. So we've got a couple dozen cameras on Starship. We've also got a bunch of cameras spread across the globe, including out in the Indian Ocean, where we've got our fun buoys floating. There goes another one. And I mean, we're using Starlink to bring all of this together. It's our drone shots you see here from our great team down here at Starbase, all connected. So Starlink not only giving us cool views off the planet, but also on the planet, help bring everybody along for all these Starship flights. So we should be just about a minute and a half where, again, as Amanda just said, we're going to relight one of those center engines. This will be the third time that we've tried this. We did it successfully back on Flight 10, and then we did it for the very first time back on Flight 6. This is not a deorbit burn. This is demonstrating essentially all of the systems you would need to do a deorbit burn. So that's obviously your Raptor engine, and then also your header tanks, your smaller tanks in the nose cone, where we have liquid oxygen, liquid methane in a smaller, more easily pressurized container, which we can use for on-orbit burns. And we're also going to tap into those when we do our landing burn. So this will be a critical capability. Once we go to full orbital missions, you'll have to do a deorbit burn to break out of orbit, send it back down to Earth. But in this instance, we're already on our way back down towards Earth. So this is just going to demonstrate the capability of turning one of these engines on. We should be coming up in just about 20 seconds or so, looking for one of those Raptor engines to turn back on. They've been off since we completed that successful ascent burn almost 30 minutes ago. Here we go.
Oh, Raptor ignition. And shutdown.
All right, there was that Raptor relight. Looks like engine 3, full duration. As Dan mentioned, that's a third attempt, and we just did it 3 times in a row. So congrats to the team, the ship team, Raptor team. And then there we heard nominal second orbital insertion. All right, so congrats everyone on the milestone. E3. So yeah, Starlink provides us with one more path to collect data and help us rapidly iterate Starship's design.
And if the ship does manage to make it all the way to re-entry, we'll collect valuable data on the spacecraft flying through the Earth's atmosphere at hypersonic speeds, or more than 5 times the speed of sound. Re-entry is typically a portion of flight where we don't have communications with spacecraft because it's re-entering at or around orbital velocity, which is roughly 8 kilometers per second or 5 miles per second. At those insanely high speeds, the spacecraft moving through the atmosphere creates a plasma field around the vehicle.
Yeah, and that blanket of plasma distorts communication frequencies, so it's not uncommon to experience brief blackouts in communication.
Vehicle is now at maximum dynamic pressure.
All right, that was basically our reverse max Q. So most aerodynamic stress that it's going to see during reentry, we just passed through it. So we're past that. We're past peak heating.
The ship is making its turn for final approach.
And here's this kind of aggressive final turn that would essentially position it so it's right behind the launch and catch tower. Flaps holding strong. Landing burn in just under 20 seconds.
Ship landing startup.
There's our landing burn. Three down to two.
Starship has landed.